Alright, welcome to the review video for the Unit 4 test. Now the Unit 4 test is in Excel, so you'll see that what we're doing very closely models what we generally do for our projects. And so we're going to start with a control chart. We're given this data below, and these are our altimeter errors. This was from the altimeter problem from Chapter 14. They were taken from 5 altimeters each day for 20 days. Create the necessary columns and rows to generate X bar and R control charts. Use Excel functions for all calculations. So just looking at our formula sheet, we have control charts here. And let's start off with our X bar chart. So if we're looking at our X bar chart, we need this X double bar, which is the mean of mean. So let's start there. To find X bar and X double bar, what that really means is those are just the means of all of these errors for each day. So let's start with our X bar. And we're taking the average of, well, all of these errors for this day. So errors 1 through 5 for each day. And so we are just going to click and highlight all of the errors for this given day. And we could close these parentheses. We don't really have to. If you press enter, you'll get the same output. And we see that this X bar is 2.8. Now this is just the mean for day 1. If we wanted to find the mean for the other 19 days, we would have to do the same thing. Or we could just use the same idea, taking the average and fill that down for the rest of these cells. And we do that by looking at our cursor. It's sort of a white plus sign right now, and putting it over the right bottom corner of this cell until it turns black. When that happens, we click and drag down until cell 20. Great. And this will automatically give us the average for all of these days. And so we have our X bar. Alright, and now let's just refer back to our formulas and tables here. We know for our X bar chart, okay, we have our X bar, but what we're really looking for is our X double bar. The X double bar, when we have a bar over any kind of variable, it just means the mean of that variable. So when we have these 2 bars over that X, it just means the mean of the means. So it means the mean of all of these X bar values. And I'm going to do something a little bit strange. Now we know that our X double bar is just going to be this one value. So this is just going to be equal to the average of all of these X bar values. Okay, and X double bar, well, that is just 1.19. We only have one X double bar. And so what I'm going to do is I'm going to create a whole column of just 1.19. And here's why. Our ultimate goal is to create a table. And so when we create this table, this chart here, this control chart, we want this horizontal line at X double bar. So we want this center line at X double bar, and let's just go back to our notes really quickly to see what this looks like. We want this red horizontal line here. And one of the best ways to create a horizontal line in a chart is just to create an entire column full of this value. So it's essentially plotting 20 points at the Y value of 1.19. And so to do that, we're just going to copy 1.19, copying this value, and then going ahead, highlighting all the cells we want to fill in with 1.19, and pressing paste. And I'm just using the keyboard shortcuts to do that. And clearly this is not what we want. So what Excel automatically does is it automatically applies the same function. So each one of these is a different average. That's not what we want. We just want 1.19 all the way down this column. So let's adjust what we're pasting, and we want to paste values only, giving us a whole column of this X double bar. And that's going to come in handy again when we create that chart. So let's go back to our formulas and tables. All right, so for our X bar chart, we've got our center line at X double bar. We've got part of our upper and lower control limits, and we need this R bar. We need A2 and we need R bar. Well, R bar is just going to be the average range. But how do we find the average range? Well, first we need the range of each of these days. And so our range, we remember that oddly enough, this Excel does not have a function for range. So we're going to have to take the maximum of these different altimeter readings per day and subtract the minimum. So we are going to get that this is equal to the maximum of one of these values minus the minimum of, and now we're just going to highlight the same 5 values. Great, and this gives us the range. And this time for the range, we want to know the range of each of these days. And so we're going to simply just fill this down, and this is going to give us all of these ranges. Now when we find our bar, we just want the average of all of these ranges, and so we can take the average of this column of ranges and we get 30.65. Looking back at our formulas and tables, we're looking at the horizontal lines. Whatever we want to be a horizontal line on our chart, we're going to need to create a column of. We want a horizontal line as the center line. We want a horizontal lower and upper control limit line. But this R bar is just an intermediate step, so there's no need to fill this down through this entire column. And to keep our chart organized, if we're going to make this a chart of all of our columns, well, I can just move this R bar. I'm going to cut and paste it down here. And down here, I'm also going to put some of my constants. So remember, in our formulas, we have this A2. And this A2 is given in our control chart constants, and this is all we're doing. We're just looking at this chart of constants. Our subgroup size, because in this case we have 5 samples for each day, our subgroup size of 5 will give us an A2, that constant, of 0.577. So let's make a note of that in here. So A2. Now we have everything we need to find our upper and our lower control limits, and because we want these to be horizontal lines on our chart, we're going to need to make these entire columns. And so let's go back up here, and we are worried about the lower control limit for X bar chart and the upper control limit. For our X bar chart. Okay, and this formula is going to come from, for our lower control limit, X double bar minus A2 times R bar. And so we want all of these, at least the first cell in each column, to be a live cell. And what that means is that we're going to just use an equation and other cells in this Excel spreadsheet to find that value. So this is going to be X double bar, okay, 1.19 minus the quantity R bar, which is 30.65, times this constant A2. And we have our lower control limit of negative 16.495. Because we want this to be a horizontal line, let's just copy this to the rest of the column. Okay, and for some reason sometimes it remembers the last value we copied and pasted. And so if we go down and click values only, it will just repeat whatever we had most recently copied. Alright, and so for our upper control limit, we're going to use a similar process. The only difference in the formula is that now we are adding here instead of subtracting. So we are taking this to be our x double bar plus the product of r bar and A2, and giving us 18.87505, and let's copy this and paste. Okay. Looking at these cells, well, I mean, we've got 5 places, 5 numbers after the decimal place here. We don't really need all that. In fact, it's a little bit distracting. So let's just go to the hundredths place. And this is not a hard rule. This is just to clean this up a little bit. So highlighting all of the cells that we want to change the format of. Going to Format Cells. Our category is a number. And now we're moving this to 2 decimal places, pressing OK. And that just looks a little bit better. So let's refer back to our formulas and tables one more time. We've got our upper control limit, we've got our center line, we've got our lower control limit, and we remember these individual points we plot. The individual points we plot for an X bar chart are just the X bar values. And so we're going to create our X bar chart. To create the X bar chart, we need to start by just highlighting all of the values we want to include. So we know we're going to include all of our individual X bar values. We know we're going to include our X double bar. And we know we're going to include our lower and our upper control limits. Okay, and this is just the X bar chart. This R is going to come in later. So, for our X bar chart, let's go to Insert, and we have our different types of charts. And we're going to click the top left, just the regular line graph if you have a little bit of a different setup. And we can see what happens. We can see where these horizontal lines come from. These horizontal lines are just really a series of these 20 points plotted at y equals 18.88 or negative 16.50, or in the case of our center line at 1.19. And so the only thing we have left to do, as much as I want to give you as much guidance as I can without just handing you the project, you will have to have certain requirements for the chart. We're going to have to adjust this title, and we can do that by just clicking on the title and calling it something like X bar chart. Okay, now we're also going to need to do things like label our different axes, and to do that, clicking on the chart, we can add a chart element. This is where we can add axis labels and titles. So we can adjust all of that here, and we will be very clear what we are going to require. We also need you to label these upper and lower control limits and this X double bar center line in the middle. So now for our R chart. Looking at our R chart, we're going to need this R bar. And again, this R bar just means the mean of all of our R values. R just stands for range, and let's move this X bar chart over a little bit. Okay, and we need our R bar. And so this is going to be of all of these R values. Okay. And looking back at our formulas and tables, this R bar is going to be a center line. Since this is a center line, we just want to copy this down the whole column so it shows up in our chart as a horizontal line. And so we can copy this value down to the whole column. And just adjust that so it marks as values only. And we've got our R bar. Finally, we need our lower control limits and our upper control limits for the R chart. Okay, and so for our R chart, we've got slightly different constants here, and we've got different formulas, and the formula is a little bit simpler for an R chart, but we need constants D3 and D4. Remembering that our subgroup size is N because we're taking 5, our subgroup size is 5 because we're taking 5 altimeters from each day. We have a D3 of 0 and a D4 of 2.114. So let's make note of that here. So our D3 is just 0, and our D4 is equal to 2.114. All right, and our lower control limit is just equal to D3 times R bar. Easy enough, we can see that that is 0. And we can fill down this whole column because we want this to be a vertical line. Our upper control limit is equal to this constant D4 times our R bar value, and we get 64.7941. And let's also fill this down the entire column, adjusting this to be values only. And let's just format these cells so we're only holding on to 2 numbers after the decimal place. So going to format, then number, and making our decimal places 2 and pressing OK. And that looks a lot better. And so now for our R chart. In the same way, we need all of our individual values to come from this R. So just highlighting all of these R values. Our center line is our R bar, and we need the lower and upper control limits. Okay, now that we have all of these highlighted, going to insert, and then to our line graph. All right. And here's our chart for our ranges. And in the same way, we're going to need to just format this to fit all of those requirements using these add chart elements. And a lot of times it's easier to use the quick layout just to meet certain graph requirements in the easiest way possible. So, in general, another thing we're going to ask for is for any values that are above or below the control limits. And we can see here our lower control limit, it's a little bit hard to see, but we know for an R chart it's 0. And so we don't have any values of R below our lower control limit, but we do have this point above the upper control limit. And we can see that that value is 72. And we can see another value here that violates at 77. And so if we were asked to highlight the cells, we will just simply use this fill color button to highlight all of the cells that meet that requirement. Okay, so in a general way, just make sure you pay attention for all of the formatting requirements, and please ask if you have any questions. I understand that not everyone has the same version of Excel, So if something is just not working out, please just let me know and I will do my best to assist you. All right, and now we're on our next topic of indices. So here we're given a table with prices and quantities of this list of 4 different resources during 1990 and 2009. So we need to find all of these indices: simple aggregate index, Laspeyres, POSH, Fisher's ideal, and the value index. And in this problem, we're kind of on our own here as to create these columns and formulas necessary to find all of these indices. The main thing required is that everything needs to be labeled and relatively organized. And in this problem, we know whenever we have any kind of indices, one of the time periods is our base period, and in this case 1990 is going to be our base, and we are to find the index of the year 2009. So for the simple aggregate index, we know that that comes from just adding up the price from each year and then dividing the current price, the sum of the current price, by the sum of the base price and multiplying by 100. So let's find the sum of the price. And if we're going to find the sum, we have to use this Excel function, which is equals sum, and then just highlighting all of the cells. Let's see. Not forgetting our parentheses here. Okay, and we'll find the sum of the current price as well. Alright, so we have our two sums, and because we're labeling everything, we need to make this clear that these are our sums. Okay, and we can just move that over to the right. Alright, so we have our two sums. So to find the simple aggregate index, alright, well, we're taking the current or most recent sum of the price and dividing by the base price, the sum of the base price, and then multiplying by 100. And so our simple aggregate index is 380.02 something. And we're eventually going to want to round to something like the hundredths place, but we can just do that at the end for all of these cells. It does not matter. All right, so simple aggregate index is, well, pretty simple. And now for the Laspeyres price index, let's go back and remember how to find the Laspeyres price index. So let's refer to our notes. Now for the Laspeyres method. So for this Laspeyres index, here in the numerator we have P, T, Q, naught. What that means is that it's our current price, or most recent price, and our base quantity. So now in the rest of these 4 indices, we're also taking the quantity into consideration. And so, you can tell that the simple aggregate index isn't necessarily the most accurate. It doesn't include all of the information. So Laspeyres, PT Q naught divided by P naught Q naught. So let's create some columns. So we have our Laspeyres index. All right. And for the Laspeyres index, we're going to find the PT Q naught value. And I want to make this a subscript, and your keyboard shortcuts might be different, or you might not have keyboard shortcuts, but I'm highlighting whichever letter I want to make a subscript and pressing Command 1, and I have a Mac. So making that a subscript and getting out of my subscript to go to Q naught. Okay, so PTQ naught. Well, what that means is that we are taking all 4 of these current price values. So just highlighting this column, and then we are multiplying the base quantity, so the quantity from 1990. And for example, this first cell, and we can check our cell inputs up here. So this first cell, 760, comes from E8 and F8. So E8 and F8, right? So we're just multiplying these two values. Then in the next row, we're multiplying these two values and so on. So we get 4 different values here. All right, and now we need P naught, Q naught. All right, and in the same way, we're going to multiply the base price by the base quantity. So this is going to equal the base price times the base quantity. Okay, but going back to our formula for L'Esper's, we're taking these sums, the sum of the numerator and the sum of the denominator. So now, with our 4 different values here and here, now let's find the sum of each of these. Okay, and we can just move this over a little bit. Okay, we have our sum here, and we are also finding the sum for our P naught, Q naught. Okay, and finally, the sum of PTQ naught, let's put some parentheses, divided by the sum of P naught, Q naught, multiplied by 100. Okay, and we're not going to do the rest of these. Now, I will give you an Excel sheet with all the solutions on it. So here you'll be able to see the active cells for Posh, Fisher's, and value index. And all of these we're just using the formulas that are in your class notes from last week. So for the Posh price index and for the value index, we have a similar method here with the L'Esper's. And then for Fisher's ideal, going back to our notes really quickly, for Fisher's ideal, we can see that we're essentially just taking the average of L'Esper's and Posh. All right, but before I leave you, let's just format these cells again. And we're just going to right-click, format cells, going to number, category number, and we just want to round to 2 decimal places. It just looks a lot neater. Okay, and there we have it. And so these cells are now properly formatted, and we would continue to create these columns and label them appropriately to find the rest of these 3 indices. So you will see that Excel sheet attached along with this video. So the last part of your unit test is, we kind of talked about how this would be included in either your project or your test, which is really kind of like an Excel project. We're going to be talking about this moving average. And what the moving average does is it takes some data that it doesn't necessarily have to have a pattern, it doesn't necessarily have to be cyclical, but it takes some data for which it's difficult to find a trend line, and it essentially pulls all of these means from different groups of this data inward to end up forming a fairly accurate trend line. So let's look at an example of this. Okay, so we have this data given here. It gives the number of strikes that workers had from 1960 to 1987. We're constructing a 3-year, 5-year, and 7-year moving average. We're then going to use that moving average, those moving averages, to plot all of them on a time series graph so we can see what's happening. And ultimately, we're using the 7-year moving average to find a trend line. And that's why we use moving averages. All right, so let's start with our 3-year moving average. And we find the 3-year moving average by just grouping all of these frequencies into groups of 3 and then finding the average of each group. So that means that, and generally when we do this, if I find a 3-year moving average, I'm looking at, and we have the coded time t just so we can more easily refer to our cells here. So I'm looking at coded time 1, 2, and 3. And so I'm going to put my 3-year moving average right in the middle. And I'm going to say that is equal to the average of the frequency from 1 to 3. Okay, 5,487, and I always just like to look at these 3 different frequencies just to make sure we included the proper values, and it looks like we did. So now we're going to do that for all of these other cells, but yes, there is an easier way. All right, so let's fill this value down. And we're not going to fill it all the way down. So if I'm thinking, I put this 3-year moving average in between coded times 1 through 3, so adjacent to coded time 2, well then I'm also going to need to leave 1 open space at the bottom here. Okay, and we'll see why. So let's just ensure that this last value should be the average of coded times 18 through 20. And this is the average of D24 to D26. Great, this is the average of the last 3 times. If we pulled this all the way down to the bottom, we would end up getting an average of this empty cell, and that would skew our values, so we don't want that. Okay, so we have our 3-year moving average, and now we need to find our 5-year moving average. All right, nothing crazy here. Now we're just finding averages of these groups of 5. So we're going from 1 through 5, and we'll try to put this somewhere in the middle. Let's say about here, and we can say that this is equal to from 1 through 5. Okay, and let's just fill this down. And in this case, so because we are going from 1 through 5, we are including values from coded time 4 and 5, and so we should leave 2 open spaces underneath here. Okay, and let's just ensure that this is the correct data. 22 to 26, D22 to 26. Great, we've got the last 5 values here. And so we're going to do the same exact thing with this 7-year. And just putting that somewhere in the middle here. Now we are taking the average of these groups of 7 frequencies. And so just highlighting the first 7 frequencies. And we're going to fill this down. Let's just make sure we fill it down to the next value. So this is at 4, and so we're going to have 3 open spaces below. Okay. And there we go. Just double checking the last of these values. D20 to D26. Great. Okay, so we have all of our moving averages. Let's just clean all of these up a little bit, and by that I mean just format the cells so we can round to the hundredths place. So formatting the cells, going to number, 2 decimal places, looks good. Didn't change anything too much here. So we have our moving averages, and now let's really see what happens when we actually graph these. So before we do any kind of graphing, we just need to highlight everything that we're looking for. So we are highlighting R. Now we have this coded time t because so our year is going to be our x-axis, and as you can see, if we have all of these years listed in our x-axis, it is going to look like a very jumbled series of numbers. And so that's what our coded time allows us to do. It just allows us to actually see our x-axis and make it look halfway decent. Okay, so we're just highlighting all of our values. We are inserting chart, and I'm just going to plot these points this time, so the line with markers. Okay, and we can see what happens, and let's zoom in a little bit. Alright, now to get a better idea of what this looks like, because it's a little bit smushed, we can just reconfigure this y-axis, this vertical axis, by right-clicking and going to Format Axis. Okay, so here we can adjust our minimum and maximum, and our lowest value, I mean, we don't go past 4,000, so we can play it safe and go with 3,500 as our minimum. And a maximum, I think 6,500 should do the trick. Okay, and it looks like we can even just go to 4,000. All right. Few things we have to do. We need a different title, and the title can be something like Number of Worker Strikes in the US from 68 to 87. All right. We can add these chart elements like an axis title for our vertical and for our horizontal. Okay. So when we go to label our different series, we know that what this moving average did was, as we increased the number of years, this got closer and closer to a straight line. And we can see that the most linear graph is given by the 7-year moving average, and the one with the most peaks and valleys, the least linear you could say, is given by just the original data values. All right, and finally the last thing we have to do is we have to find a linear regression model. Now we know we're doing this based on the most accurate moving average, which is the 7-year moving average. And finally, to get this linear regression model, we're going to go to Add Chart Element, go down to Trend Line, and then we want the linear forecast trend line. The linear trend line does not give us that same regression equation that the linear forecast does. And so we're going to base this on our most accurate, our most linear moving average, which is going to be our 7-year. And we can see that in this case it's series 4. And we have that trend line. Okay, and finally, to display this equation, we can right-click on this actual trend line, go to Format Trend Line, and then we have an option to display equation on chart. And let's display the R-squared value on the chart as well. And that showed up somewhere. All right. And so now we have an equation for this trend line. Now the reason we have this R-squared value displayed is because we remember that this will tell us how accurate our equation is, so how likely it is to accurately predict this next value. And an R-squared of 0.9 is very high, which means that our 7-year moving average forms a linear regression equation that is a very good predictor of any kind of future trends. And that's why in the world of stocks or any kind of business, you will actually see a lot of these different trend lines being created. And now on this test, you might have to fill in a few text boxes, just asking questions that help you make sense of this data. But this review contains all of the actual Excel knowledge you will need. So I hope these videos were helpful.